when we are done here going through these couple examples, I'm going to have you do the worksheet that's in Schoology and also watch or submit your answers to me to that worksheet in Schoology by taking pictures of your work. So here we go with just a couple examples using conditional probability and our formula here. Okay, so when we start finding, we have two events here, event X and event Y, and so they're just giving us the actual probabilities of each of these events, not really relating it to a particular real life problem, but just looking at the numbers. When we look at this then and use the formula, we know that by the conditional probability formula, we would have the probability of X given Y is equal to the probability of X intersect Y, or X and Y, divided by the probability of Y. And if we look at the numbers that are listed here, they tell us the probability of X and Y is 0.28. That's divided by the probability of Y, and in this particular problem, it's 0.42. So I go ahead and I divide those just by looking at the formula. It would be 0.667. The conditional probability finding Y given X by the formula is going to be P of X intersect Y again, but now this time I'm dividing by the probability of X, condition that already happened or was given. The probability of X intersect Y again is 0.28, and the probability of X from our example is 0.53, so the simple division of those two is 0.528, and so on, rounding. Here's an example with a fair die being rolled. So the probability that a 2 is rolled given the rolled is even. If I'm going to set that up, so I could go ahead and put in an A and a B here if I want to. So the probability that a 2 is rolled might be event A, and then the probability, or given this B part, the number rolled is even. If I go ahead and look at that, then this would be, I'm finding P, the probability of event A, given event B. Using my formula then, I would know that I'm finding the probability of A and B divided by the probability of event B. Sometimes it's helpful to make symbols, sometimes it's better to leave it in words. So the probability in words of it being 2 and even out of the probability of it being divided by the probability of it being even. So let's look at what those probabilities would be. If we're only rolling one fair die, then our sample space is 1, 2, 3, 4, 5, and 6. I have 6 outcomes. So I know that my ratio on top is going to be out of 6. The probability that you get a 2 and it's even is just going to be one of those chances, 1 out of 6. The only place that can happen is when it's a 2 and even. It happens one time out of 6. The probability of it being an even number, however, out of this group is going to be a 2, a 4, and a 6. So in that case, my ratio or probability would be 3 out of 6, or a half. And when I go ahead and divide these two, I get a 6th times the reciprocal, 6 over 3, if I divide. And my 6's are going to really cancel out, so I'm going to end up getting the probability of a 2 is rolled, given the number rolled first is even, or given that it's an even number, it's 1/3. Okay, so let's look at the next one. The probability of rolling an even given the number rolled is odd. That would be, let's rewrite this with the formula. It would be probability then of even and odd divided by the probability of it being odd. So again, looking at our sample space up here, let's get rid of our highlights. Okay, we still have our sample space. And we can see that the probability of it being even and odd, that can't happen. We can't have an even and an odd number at the same time. So in this case, the top is going to be 0 out of 6 times. And the probability that you would draw an odd, obviously, would be 3 out of 6. So when we divide that by 0 and multiply by the reciprocal, right, we're going to be 0 divided by 3. We know that that answer would be, this is impossible. So it's impossible for you to roll an even number given the number rolled is odd. Okay, and we could just probably see that from actually listening to what that actually said, but it's kind of nice for those of you that like to have formulas step by step. That's sort of how I operate as well. I like to have a formula. I like to work through it. Sometimes it's harder for me to just comprehend and understand without that formula in front of me. I hope this helps you now as you work forward through your conditional probability worksheet. I do have the answers to that. Well, actually, I want you to send it to me so I can look at your work and critique it and get it back to you so you can make some corrections on conditional probability. So good luck with that. That's all we're going to do this week with Easter coming. Hopefully, I want that worksheet from you by, let's say, Thursday, so that I can grade that over Easter break and kind of give you some input starting on Tuesday the following week. So you have Friday and Monday off for Easter. I hope you have an awesome break, and we will talk to you soon.